Welcome, everyone. Thank you for coming to my talk. We're going to discuss a bit about our approach on managing AWS organizations. So I will be sharing with you the experience we had at Nexink in managing 70 plus AWS accounts, the different ways we approach the security overall. Just before we begin, to explain a bit what Nexink is, our mission is to delight people at work. So as you can see, we have more than 1,000 clients. We have 15 million cloud endpoints sending data to our infrastructures. We operate in 10 AWS regions. We have dozens of clusters, and we're processing trillions of events daily. Just a bit about myself. I started my career as a Linux sysadmin, then I moved to pentest, and now I've switched more to a cloud journey, and I work at Nexink. Just an overview of the agenda. We're going to start a bit discussing about the AWS organization structure. So I'm going to say AWS a lot in the talk, so bear with me. The AWS organization, we deployed it with a specific structure. I will touch a little bit about the services that work generally with the AWS organization. SCPs, I will explain a bit later what an SCP is and how we use them. We'll focus a little bit as well on access and user management. We distinguish between two types of accesses. One is permanent and the other one is temporary, and discuss a bit about access and management in terms of infrastructure as code, how we deploy some of the infrastructure. Log centralization as well, to give some ideas on how we did all the centralization of the logs. We faced some challenges there as well, so I hope that this could help some others that are asking themselves the same questions. I will explain a bit how we try to protect our backups, specifically for everything that is ransomware related, some configuration hardenings, and some takeaways. This is how the AWS organization is structured. You have, obviously, the organization and the management account. It's fully deployed using infrastructure as code. We use Terraform and TerraGrunt. I will explain a bit in the next slide how we use TerraGrunt and why we decided to use TerraGrunt as well. And the reason we deploy all of it through infrastructure as code, it's pretty obvious. Reproducible deployments, easy to roll back. Currently, we have 70 plus AWS accounts. So each time I say AWS account, it's a full tenant. The organization is managed, as I said, through infrastructure as code that is stored on GitHub, a GitHub repository which is owned by the security team. But it can also be used by engineering teams if they want to contribute, if they want to make a request, change something, change a policy, or deploy something new. They can definitely create a pull request. It has to be reviewed by the security team, and then it can be deployed. The one thing to note is that each time you create an organization, you will have a management account. This account has basically all the permissions on all the child accounts that will be created in the organization. So this is the account you have to protect the most. You definitely have to block all access to this account. And every service that you use in the organization, you can have delegation for that. We will touch on that in the next slides. And the organization account role, it's a role that is deployed by default. Each time you will create an account in the organization, that role will be created in the account, and it can only be assumed by the management one. This is how we structured the repository that is managing the organization. The reason we use TerraGrunt is because it allows us to have a folder per resource. And when I say resource, it's not a Terraform resource. It could be a bunch of Terraform modules which together will deploy something. It can be a role, it can be something else. We have separate states for everything that we deploy in the folder. It's also possible to use, TerraGrunt allows you to easily manage dependencies. So for example, if you have a module that depends on another module, you can specify that either if it's to have the output of the other module or basically saying, I need A before I can deploy B. The deployments are really fast because the plans are way smaller. Since you don't, let's say, for example, you need to deploy 50 services, you won't have a plan that will do all the 50 services. You can break down all of the services independently, and that way you also limit the blast radius. So if something goes wrong, it goes wrong only on a specific service that you deployed, and it doesn't affect all the rest. One thing to mention is that what we deploy with the code that I just explained before, we don't deploy infrastructure per se, which means we don't deploy EC2 instances, we don't deploy anything that will be used by our engineering teams. The only thing and the only purpose of this repository is to manage IAM users, roles, integrations, if you have integrations with specific tools that you want to scan the accounts. But we do deploy some hardening configurations, baseline that we call baseline for each account. All the policies we use in general for all the accounts and as well the SCPs. Like I mentioned, when you use an AWS organization, it actually allows you to use specific AWS services. And these services can, if enabled at the organization level, will automatically be enabled in all the accounts. You can have an account which will be the delegated admin of that specific service. So this way, you don't connect and you don't manage that service from the management account. Like I said before, it's one of the most critical accounts you have in your organization. You have to protect it at all costs. So you do the delegation to dedicated accounts. Like you saw before in the organization, we have a security account. That account will only be admin of specific services that we are using. One service which is really important for us is the IAM Identity Center. AWS just renamed the service. Before it was called AWS SSO, I think. So that's why I mentioned SSO. You can actually have one for the entire organization, meaning that each time you provision some access in this identity center, it will automatically be provisioned in the accounts where it's configured, which means pretty much all the accounts of the organization. It's a regional service, so if it goes down, you don't have SSO anymore, probably it would be a good idea to have a backup plan as well. You can actually have an instance per account, which is possible, I think, since a couple of months ago. AWS has made this possible. It wasn't possible before. You can delegate the administration of this account, and you should delegate the administration of this account, because this service will be managed by the management account. But you don't want people connecting to this account, and you still want to manage the service. So you have to do the delegation to a dedicated account. But there's one caveat with that, is that once you do the delegation, that administrator account cannot change permission sets that are deployed in the management account, which is actually good. And I just gave you an example of an SCP. If you want to stop the creation of instances per account, just in case you have people with high level of privileges in different accounts, you actually want to prevent them from creating identity providers. So what's an SCP? You can think of an SCP as a GPO for Active Directory. I think pretty much everyone knows what a GPO is in the world of Windows. That you can apply to an organization unit or to an AD object. In this case, it could be an AWS account or an organization unit of the AWS organization. We do have globally applied SCPs. And as you can see, we block some of the dangerous actions. We block the root account. So in AWS, when you create a tenant, an account, you will have what is called the root account. And that root account is not bound by IAM permissions, which means that if you can connect with that account, you can do pretty much everything in the account. The only way to block it is to use the AWS organizations. And you have an SCP that will actually allow you to block any action using that root account. We also block the creation of the keys, so you can't connect programmatically either. We block specific actions that the different accounts can perform on their own. We also do some restrictions on S3 public access block. I think you've pretty much seen in the media that usually Many S3 buckets are found public with confidential information. And we also disable some actions that might allow highly privileged people in specific accounts to delete specific services or components. One thing to mention about the region allow list per environment, why this is important is if you have sandbox, you may have staging, production, so on and so forth. You don't need all the AWS regions to be available in those accounts. So you can restrict the regions and say, in sandbox, I have less regions. You limit the blast radius in case of issues. You reduce the attack surface, but it also saves cost because you might not want to deploy in specific regions which are more expensive. And you can do it per environment, like I said, or you can do it by account as well. The problem, if you do this, is that usually you will have users that will come and complain that they have access denied errors. The reason is that all the default AWS regions, you cannot disable them. You can prevent someone from making an action in that region, but you cannot actually disable it. And you need to be mindful that you have some quotas that apply to SCPs, so you can't just apply, same as in Active Directory, tons and tons of SCPs on the organization units or the accounts. You have to define a strategy before you actually start applying them on how many you would apply at the organization unit level if you actually want to apply as well at the account level. We actually do both. We apply at the organization level, at some OU level, but we also have per account. And as you can see, we define everything as YAML. What we do actually, what this file says is that you define an alias for your account. You actually need an email always. We define some variables. Those variables will actually be tags on the account. We restrict services, which means if a service is not listed there, it won't work. Even if you're an admin of the account, that service cannot work unless it's listed here. And we also do restrictions on VPC peerings, because if you're an admin of an account, you have a VPC, so you have your networking stack. You might eventually want to do a VPC peering, which actually allows you to communicate with different accounts that might be or not in your organization. So that's something we want to restrict, and we want to approve when it's done. And that's why we also built the capability to actually do the listing. The only problem, if you start listing services as we do, is that at some point, depending on the service you want to use, you will face issues because, like I mentioned here, if you use EC2, you actually need all of these services to use EC2 in most cases. And how we found this out actually is by using SIEM logs. So we did debugging sessions. Okay, it's not working. Which service is doing the actions? So this is one of the caveats by restricting services. But from a security perspective, it's very powerful because if you have an account that only needs to run EC2, well, it can only run EC2. It can't do anything else. And the configuration abstraction as YAML is really good to have because you might have people in your organization that might not know Terraform, or they know Terraform, but they don't know TerraGrunt. And YAML, everyone can read. It's super simple to read. It's easy to parse. And everyone can understand and make a change if they need to do a change. The problem with SCPs is that you can have two types. You can have deny and allow. I encourage you strongly to never use the allow ones because it's very, very painful to use and it starts to become really difficult. It's better to use the deny version of the SCP. And the reason I put this here is that by default in AWS, everything is blocked. And not only that, if there's an explicit deny, even if there's an allow, the explicit deny will always win. And that's important to note when you do the SCPs as well. Like mentioned previously, tagging accounts is very useful. We actually use those tags heavily. We use them in our SIEM alerts to distinguish, is it production? Is it critical? Also for billing, and as well the owners. when you manage so many accounts, in the end, you need to know who's running workloads in that account, who's responsible for those workloads, who do we need to contact in case there's a problem. And all of that information is always tagged in the account. So now we'll go a little bit through the basic SCPs that we apply at the organization level. The first one, like I said, is block the root account usage. There's no reason, almost, to use the root account in an AWS organization. If you actually have to do that, it's because either you want to change the name of the account, or the contact email, or the contact information of the account. That's pretty much the only reason you would want to use the root account, which should most probably never happen. But if you actually need to use that, in the first slide, when I was showing the organization structure, we do have an organization unit where there's no SCP blocking the root usage, which means we can move the account into that organization unit, perform the action we need, and then we move it back. Block the creation of the keys. The root account, since it's not supposed to be used, well, you shouldn't have any keys either. So there's no reason of having that, and it should be blocked. We also protect sensitive IAM roles. And when I say sensitive IAM roles, it's roles that we use to manage the organization, manage specific configurations in the accounts. And we actually try to leverage a bit more IAM paths, because I think they're underused. So for example, what we do is we have an org admin path. And as you can see, this SCP is applied at the organization level. So whichever role the security team deploys, regardless in which account, no one, and even if they're an admin of the account, will be able to change either the role or the policies that are attached to the role. So that won't be possible, which guarantees that when we make a deployment of specific configurations, permissions into an account, absolutely no one can change them, even if they have admin access to the account. And you can then actually extend the same logic to have for other paths that, depending on the use case you might have, you could have for EKS admin, where you could say only this specific role can probably delete a cluster. It would be bad if admins can delete EKS clusters in production. So that's something to have in mind. And as you can see here, there's always an exception. So each time we create an SCP that blocks something, we always say, except if it's this role, which is the one that is automatically deployed in all the accounts. And this role can only be assumed and used from the organization management account. Basically, only the security team has access to this role, which means that we don't have any restrictions, regardless of the organization unit or the account, but we impose those restrictions on the people using the workloads in the account. Again, you can tag and apply tags in AWS. It's super useful. You should use it as much as possible. And with AWS organizations, you can actually enforce tags and tag values. In this configuration, you can actually see that you can have a tag environment, and the only values that people could add to this tag would be these values here, which means you enforce and you say, okay, if all the resources in my accounts or one specific account need to have specific tags, it can be billing, it can be environment, it can be owner team, it can be whatever you need it to be. You enforce specific values. And once you've set this at the organization level, you can use an SCP to specifically enforce, and you would say each time someone creates an EC2 instance, they can't create the instance unless they add the tag with one of these values. It becomes really powerful because you can actually then go a bit deeper in the access management, which is the ABAC one, attribute-based access, in AWS. A lot of services actually support ABAC, not all of them. You have a list in the AWS documentation, but still this is good practice to have, so that imagine if you have 70 plus AWS accounts, if there's an incident on an instance or on a service, you have absolutely no idea who's the owner of the service, who deployed it, is it prod, is it dev, is it critical, so on and so forth. So use tags extensively. This actually is a pretty easy SCP that we applied. which is disabling Lambda URLs if they're not authenticated. It might seem not important at all, but actually we were surprised because by default, Lambdas didn't have this feature in the past. So AWS released this feature, which actually allowed people with some level of access in AWS to make a Lambda publicly available, but with no authentication. So we actually had to create immediately this SCP and apply it to all the organization so that no one can actually make Lambdas publicly available without authentication. The reason I'm saying, and I'm actually showing this, is that it means not only if you do make restrictions with SCPs at the organization level, at some point you still need to stay up to date with the AWS features, which features they release. If it's released, can it be something like this one, for example, where I can make publicly available the resources without zero authentication so that anyone can target these services? And this is actually a problem. If you do the service approach per account or per organization unit, you can actually state if this account is supposed to use EC2, well, even without this SCP, since they're only allowed to use EC2 instances, they won't be able to deploy other resources. So that's that's why it's so powerful to start restricting services on accounts. We also block some dangerous action. I mean, I didn't put all the actions here because the screenshot was too big. But you can imagine anything that you don't want your users or your administrators to do in a specific account or in a multitude of accounts. You can actually say, I'm listing all of these IAM actions and no one can do these actions except if it's the role that is managing the entire organization. There's one catch with SCPs is that they have a maximum size. You cannot exceed this size. And the seed, which is this one, counts in the size of the SCP. So once you start reaching a specific size, it's actually good to remove the seeds from the policies. I left them there just to give a bit more explanation on what it does. And there's also another catch is that since you're doing denies in IAM, you actually have to extensively learn the IAM language. The way that each IAM policy is treated is completely different if you use deny or allow, even in the conditions. And one thing that I didn't mention is that what we do here is that we deny, for example, creating users and access keys, unless if it's this account. So with this role, you can actually perform those actions. You can give admin access to an account to, I don't know, let's say the SRE team that manages the infrastructure in that specific account. They won't be able to have these actions, which means that each time they need to have an IAM user, for example, let's say, they have to reach out to the security team or do a pull request on the repository and say, hey, I need an IAM user. Can you please create it for me? So that we make sure that we know a new IAM user is being created, what is it used for, what permissions that user will have, so on and so forth. So we have full visibility of what's being done because they can't do it without our approval. Oh yeah, and one thing is you should probably block even your administrators from registering domain names. That's something that is really good to have. Identity providers. I mentioned before that you have the IAM Identity Center of AWS, but you can actually also register specific identity providers. It could be GitHub, it could be OAuth 0, I forgot the name of the other service. But they can be used as a persistence mechanism. If anyone can create, I mean, if you have admins or someone has admin level access, and they can create identity providers, they can create roles, which you have no idea about. It actually happened in a sandbox account where someone was doing some tests. He actually tried registering an identity provider because he wanted to test something and it didn't work. So he actually was surprised that it happened. And since we're also monitoring these actions, we reached out and we asked him, even if it's a sandbox, we are not supposed to have identity providers. So one thing I would like to highlight is monitor. So either you choose to deny those actions on specific accounts, on specific organization units, again. But if you don't do the deny, at least monitor all the actions. Each time someone registers a new one, modifies an existing one, or probably deletes one, which could also have impact on your workloads if they're using those YDC providers. You also have the possibility to create some SCP where you can actually put some conditions on this specific action. This specific action is always used when someone will assume a role that trusts a specific identity provider. I encourage you to go tomorrow to Christoph's talk, Christoph Tafani the Reaper. He will discuss a bit more about identity providers, and you'll have a bit more detail on that. What's actually sad, at least from my perspective, is that I would like to have some condition keys specifically in IAM to actually allow identity providers, but under some specific conditions. And that's actually not possible yet, because we can't have restrictions or conditions on the trust policy of the role that you create. You can actually monitor that using SIEM. In CloudTrail, it's one of the services that will actually log each and every action that is done to the AWS API. So each time someone does an API call, that will be logged by CloudTrail. You can actually see in CloudTrail the policy or the trust policy that is being used for a role when someone tries to create it. So you can eventually monitor that as well. There's one solution you could use, IAM Access Analyzer. It's a really powerful service. It can actually tell you by default. It will scan all the roles in all of your accounts if it's enabled at the organization level, and it will tell you this role has a trust policy on an account which is not part of your organization. If you see that, you should definitely investigate. KMS is the key system used by AWS to do encryption. One thing which is definitely worth doing is making sure that if someone encrypts something in your organization, that action is done, or that encryption is done with a key that you have access to and you have control over. Because you could be ransomware by someone that at some point has access to your account. Let's say that they manage to have probably a higher level of access. They start encrypting your data with a key that is their own. At that point, you've lost your data. If you don't have access to their key, you can't recover the data. So this is something you can also restrict with an SCP at the organization level, which says whichever action you do in KMS, you have to be a member of my organization, and you're not an AWS service. And obviously, it's something also good to have monitoring in place for KMS encrypt or decrypt actions, depending on the use case you might have. But just know that the amount of logs that are being generated in CloudTrail by KMS, it's really huge. And this is actually one of the reasons we created internally a tool that will help us to filter CloudTrail logs that we send to SIEM so that we reduce the amount of noise generated for some specific logs. So just know that it can have a cost. Some other secure control policies that you can use in AWS, which I strongly recommend. Like I said before, S3, I think it's the number one AWS service which is always publicly available in most of the data leaks that we see in the media. You can also do some denies in cross-environment actions. If, for example, for compliance reasons, a sandbox account should not discuss with production, and production should not talk to dev. And you can actually block that in SCPs, and you can do that by the organization unit path. You have conditions specifically available for that in IAM. EC2 instances, now AWS has implemented, now it's pretty old by now already, the EMDS v2 mechanism, which brings a bit more protections against SSRF exploits, which were used to actually exfiltrate IAM keys from EC2 instances. You can actually, in SCP, say you can't start an EC2 instance if you haven't enabled EMDS v2. So as you can see, SCPs can be very powerful. You should also deny changing the instance metadata of those EC2s, because maybe they will spin up the instance with EMDS v2 enabled, and once it's up, they will change the configuration of the EC2 instance. Prevent VPCs to get internet access for sensitive workloads. By default, when you will create a VPC, usually it will ask you, it depends if you do it through infrastructure as code, if you do it manually, but you will have an internet gateway. And generally people always configure the VPC to go through the internet gateway. Since you have an organization and you can actually have workloads separated in different accounts, you can actually have an account that does all the networking part. You put all the networking configuration in that specific account, and then you say all my workloads are in a different account, and this different account has no access to internet whatsoever unless the traffic goes through my networking account, which gives you the ability to monitor ingoing, outgoing traffic, put restrictions in place on who can connect to where. So that's something good to have. And of course, also deny VPN creation. When you're managing multiple accounts, in the end, each account will have different resources, different use cases, but in the end, if the majority of the accounts don't need to have, for example, VPN or some other specific configurations, that's also something good to do. And the EBS snapshots, this is also something you can actually prevent from downloading and sharing at the organization level. And one thing which is really important, always test an SCP before you actually apply it to a production account. Either test it on a sandbox testing account, or you put it on an organization unit which is dedicated for testing. And only once you've heavily tested that policy, you can then start applying it in production. Because, for example, if we made a mistake in one of these SCPs and we attach it to an account, it's almost instantly, it will block. So you could have production workloads going down. So it's super dangerous, always test. Access and user management. SSO for humans is the only way for us to connect to workloads. If a human needs to connect to something, it has to go through SSO. All SSO authentications have MFA enforced and IP restrictions. The reason we go through SSO is that, first of all, we don't want to have to handle AWS secret keys, which will always end up in files, in Jenkins configurations, whatever type of script people might use. So if it's human access, it has to be SSO. There has to be MFA. And we do IP restrictions. There's one reason we actually do the IP restrictions is that in AWS, once you've done the authentication, you receive a token, and that token has a lifetime. So for example, if we were to offboard someone in the company, and that person has active sessions, if we say, okay, this person shouldn't have access anymore, but if they still have that token in AWS, they will still have access because the session is still valid. However, with the IP restrictions, we have always-on VPNs, and all the traffic is going through that always-on VPN. And as soon as we disable the user's account, they have absolutely zero access to anything, basically. So we are cutting the access to almost everything instantaneously. And you can use two CLI tools, AWS Vault and Granted. They will help you to use the SSO authentication, and it actually works with the OS keychain, so you won't have to save secret keys, all of that information on disk. The only thing it will store is the token of the SSO, but that's going to be in the OS keychain, which is way more secure than having it laying around in a file. And of course, AWS secret keys, you can find them absolutely everywhere, so don't use them. But how we handle, because, okay, it's fine, you have human access, but then you still have systems that need to talk to each other. So for that, we have the service users. So for example, Jenkins. I think pretty much everyone uses Jenkins. They're all centralized in a dedicated account. Each time we need to create an IAM account, it has to be in that account, period. We can't create somewhere else. And this is actually even blocked by a security policy that says you can't create users unless if it's this account. The credentials are stored and rotated by HashiCorp Vault, and we do the rotation every 8 hours. And that's almost transparent for Jenkins. So each time Jenkins asks for the credentials, Vault will give it the credentials, but in the backend, Vault will do the management between two keys and doing the rotation every 8 hours. So the way the workloads will work is that they will have the key that they got from Jenkins, which is actually provided by HashiCorp Vault. And on top of that, you can have really cool policies on HashiCorp Vault. They need to assume a role in the target account that will allow that specific system to do X and Y actions in the account. Permanent access is also managed through code. Pretty much everything we do is infrastructure as code. We never make a change manually. That doesn't exist. If we make a change, it has to go through code. Pull requests, everything. So we use a GitHub repo as well for permanent access. And again, we use YAML abstraction because it's way easier for people to read it. It's much easier to parse. You pretty much have compliance out of the box because every change goes through pull requests. You have exactly the name of the role. That should be probably explaining a bit what it gives access to. And then we can go actually really down. We can give access either to an entire team, only the manager of the team, only the engineer of the team, the lead, intern, and we can also just specify a specific username. And all of this is then processed behind and parsed by Terraform and does all the changes automatically. Temporary access, this is actually one of the biggest issues we've had. And that is the reason we decided to build an in-house tool, which I call AWS, not the best name, but it's short. So why we didn't buy because you have tools available on the market that you can buy. You do have open source tools that pretty much do the same thing. But for us, it was like, we want to have least privilege. By using tools that are already on the market, the only thing those tools can do is actually use roles that you've pre-created in advance, which means it's not really least privilege. And that's actually the reason we decided to create our own tool, which is fully built in-house. Probably we will open source it if we have time to change it a little bit. I will explain in the next slide a bit more on how it works. And we also have a break the glass process, which means that if this tool fails, we still need to have a way to access the accounts. So we have a break the glass, which is a two-man job. One team can unlock the role, the break the glass role, but they can't use it. And the team that can use it, they can't unlock it. So you need two people to agree in order to unlock the break the glass so it can be used, which means that it's not sufficient to only compromise one account. You need to compromise multiple accounts to actually have access to it. So how did we build AWS? Again, the name is not the best, but it has AWS in the name. We used Fast API, Python, super easy. Everyone understands Python, easy to write. We used React. I'm not a web developer, so I used the thing that was the most obvious, and Jinja 2. And the reason we use Jinja 2 is that this is actually what gives us the capability to say we really do least privilege, because we use templates. And in the templates, you have actually an example here. We can have includes, we can do the IP restrictions, we can do restrictions for specific regions, and you also see that there's a time restrict included. These are the ones that we actually use in all the roles we provision, so that's why we do includes. And then we can actually cycle. So for example, I was telling you before to use ABAC, tag as much as possible. Where here, we're actually using the tags. So we're saying, okay, you can actually access the resource, but only if it's tagged, I don't know, whatever name of the project it has. So that's really, really powerful. All permissions are limited in time. By default, an access can have up to 5 days, not more. But depending on the level of access that you will request, you will have less than 5 days. For example, admin roles, they're only 24 hours. You cannot have it for more than 24 hours. After 24 hours, this policy will be valid, which means that even if we haven't removed the role that was provisioned for a specific user, by default, IAM will block all the actions of that user if it's way beyond the end date. So by building this directly in the roles that we provision when people are using the tool, it means we don't have to worry when we delete the role. Once we've provisioned the role, we know that, let's say they asked for a role that is only valid for 2 days. They can ask less if they want, but let's say they selected the full 2 days. Well, after 2 days, the role will block itself automatically, so we don't even have to remove it. Again, we do the IP restrictions on those roles as well. As I mentioned earlier, the session will always be valid. So we want, when we disable the account, they don't have access anymore because they're not coming from the IPs that are managed by our always-on VPN. And all the traffic, by the way, that goes to AWS is flowing through this always-on VPN, which means you are always reaching AWS services with specific IPs. If we block your account, well, the VPN won't be working anymore, so you don't have access. Even if you had a valid session, it won't work because IAM will see that you're not coming from the same IP, and basically you don't have access anymore. A role can be provisioned only once per account for a given user. The reason is that we didn't want, so you can actually request for privileged access to a specific account, but you can't just do that over and over and over. So once you've requested one, as long as you have that role, you can't ask the same role in the same account. Even if you ask, for example, and you say, I do have an access, but I'm asking a role that will start being valid, I don't know, next week, still, it's the same role, you can't have exactly the same. And there's a cleanup that is done every 4 hours on the expired roles just to do some cleanup. But it's not necessarily for security reasons because, as I said previously, they're automatically blocked by the date. So the way we went with the tool to give the access was an event-based approach. You have the schema is terrible, but it just highlights how it works. You have the user, so we have Okta authentication again. You will have the CloudFront, which is basically using static content from React.js. It will automate. So at this point, you have to be authenticated. You have to send the GWT token, otherwise it won't work. And even this has IP restrictions as well. Again, the always-on VPN. It goes through the API gateway, which will check your token if it's valid, if it's not expired, if you actually have access to make the request. Then it will send the request to the backend, which is the Fast API Lambda. It will write that request to DynamoDB. Then DynamoDB, because there was an insert event, it will trigger a specific Lambda that will read that event. It will go fetch the list of approvers. So this is the identity center. And here we have a group with the list of people that can actually approve when someone is asking for permission to have a specific role for a specific account. So the user never has access or cannot specify who's the approver. We always go to the source of truth and we grab the list of approvers. Yes, we use Microsoft as well, because there's a really nice integration with MS Teams and Power Automate with approvals, which means that when the approval is sent to the list of people that was fetched from here, they will all have a nice email with all the information that the user requested, which account, which role, start date, end date, which cluster they specified, which regions, etc. They will have all of that information. The same alert will also fire on Teams, so they can either approve it or reject it on the email or in Teams. And once they do the approve or reject, the email that was sent, let's say, to 50 people, because imagine that 50 people are the approvers, the email will completely change so that the others know that someone has approved or rejected the request. You have to train your approvers as well so that they understand their responsibilities. Then you have the approval state, it goes back, it fires another event, which is modify, which will actually start creating the role, and the Jinja 2 templates are in S3, so we can put as many as we want. It will provision the role, everything is absolutely logged, JSON format, of course. It sends email to the user saying you have access, you can go ahead, and then you have the cleanup. Some of the features of the tool, This is actually what we noticed, is that at first we had the tool, it was great, everyone can request access, we have approvers, but then we actually needed to build RBAC on the tool itself so that not all teams can request admin access, not all teams can request, for example, they can request admin access only in this account, but not in the other one, so on and so forth. So we actually had to do a really big extension on the RBAC model. Everything is configured in the backend, so the front end has 0 configurations. It syncs everything from the API. And the logs are immutable, so each time someone makes a request, it's never changed. The infrastructure as code, we are trying to migrate to GitHub Actions because they're way easier to use. Again, we don't use IAM keys anymore because you use the YDC integration of GitHub, but you do have some challenges as well in using GitHub Actions. You can actually go to this blog post. It explains a bit how it can be used maliciously. There are multiple ways to reference GitHub Actions. I encourage you strongly to use the hash. But that brings the complexity, which means if you have, 1,500 repositories where you have this action, when you need to update it, well, you have to go through 1,500 repositories and make an update. So, and this is how we create the YDC roles. We always specify, again, the roles that cannot be changed with the policy, with all the tags. The log centralization and the parsing, by default, everything that can be logged to S3, we send it to S3. We don't bother. Everything that cannot be sent to S3, we use CloudWatch log destinations. And the reason I put here CLI is because you can't create or see them in the UI. You can only do that through CLI. So each cloud, there's a destination per region. And all of the regions will centralize the logs and send it to a Kinesis firehose, which will do some processing and write all of that into S3. So that's the way that you can centralize everything that might not be able to send to S3. Of course, security logs are sent to CM. And all the other logs that we don't consider security, we still keep them in S3, but we can query them using Athena. It's an SQL-like service that allows you to actually query your JSON files. It depends if it's JSON Parquet. However you want to store them, you would need to parse them. But you can use Athena to query those logs as well. And VPC flow logs, I did a very big mistake when I tried playing around with VPC flow logs. Probably one of the things I should be mentioning is that if you use VPC flow logs, if you want to enable those logs, start by north-south traffic and don't enable it everywhere. I did that, and it was 70 terabytes of logs per day. So we kind of had a bad day with the infrastructure. The ransomware is pretty easy. We created a different account. In this account, we deployed exactly the same buckets as we have in the production one. With one catch is that we do the replication. There's an object lock. In AWS, object lock means you have two types. I'm going to be explaining that. We have it in compliance mode. And in compliance mode, it means that absolutely no one can change or modify that data, not even AWS. If you copy objects that are locked and you actually want to delete the data, you have to close the entire account. Okay, so that's how we protect the data. Everything is synced. We lower the retention in the source account, which actually saves us cost as well because the storage class is not the same. So we store it way less here. I put 5 days. It can be. It depends on your use case, so that you don't have to go and fetch the logs each and every time. You should definitely restrict the maximum lock object days to make sure that you can, when someone writes an object, they cannot go above the specific date you mentioned. You have that in YAML format for deployments and for configurations. You have the governance mode, which still allows you to delete. So you need to have a specific permission to actually be able to delete objects in governance mode. But if you actually want security, no one can change them. You have to use the compliance one. If you use the RTC, the compliance one, just note that if you have something that is always changing the same file on the source, the destination will always create new versions of that file. So you could end up with, 100 gigabytes here and 1 terabyte of data here. So pay attention to that when you do the copies. I'm going to go fast because I don't have time anymore. Some hardening tips. If you put MFA on everything, use YubiKeys for all the commits, no exemption on commit signing. For IAM roles, make sure you have a central repository so that people that use EKS, at least security team, is aware of the roles that are being deployed. And don't use Bastion hosts with SSH open to the internet. You have SSM, which is an AWS service, which allows you to have exactly almost the same thing, but without opening anything to the internet. And some recommendations. I will put the slides online so that you can have access to them. If there's one thing I would like to take from the talk is also that these tools are a must. You cannot have cloud security without using CSPM. The CSPM is actually what will allow you to see all the configurations of everything that is deployed in your cloud environment and see if they match with your security standard. Sorry, I had to stop here.